Okay, in this video we're going to talk about energy. Energy is the ability to do work, or the ability to exert a force through a distance or exert a force through a change of position. Energy is measured in joules. Specifically, I'm going to talk about potential energy and kinetic energy. Potential energy is just energy of position. Easy to remember. Both start the letter P. Kinetic energy is energy of motion. The potential energy can be converted to kinetic energy as soon as that energy of the position of an object, as soon as that object becomes in motion, the energy of position now becomes energy of motion. For example, let's say this baseball is a meter off the table. Because of that height, it has stored potential energy due to gravity. And as soon as I let go, that potential energy becomes energy of motion. And as soon as that height starts to decrease, some of that potential energy gets converted to kinetic energy. Halfway down, it's even. But as soon as I eliminate all of that height, all of that stored potential energy is now energy of motion. And we can use that to calculate speed as well. So let me model that to you here. If I use my little car ramp, this box is 10 centimeters high off the table. And it takes this car about 2 seconds to run the track here. And notice that height gives the car energy. How do I know? Well, if I eliminate that height, there's no change of motion. So that starting height is giving the car stored energy. And as soon as I let go, potential energy becomes kinetic energy or energy of motion. So I doubled my height. Now I have 20 centimeters of height. If the previous run was about 2 seconds, this is going to be closer to 1 second. You'll see it goes much faster. And what do you see here? There's more potential energy. That translates into more kinetic energy, which we can observe that by a higher speed. I can calculate that speed. Like I said, it's about 1.3 seconds. If I take the distance here, which is 1.7 meters, and I divide that 1.7 meters by the 1.2 seconds, it's about 1.4, it's roughly about 1.5 meters per second is its speed. So hold that thought. Let's calculate it and see if it matches up or not. So here's my formulas for potential energy. Potential energy is the mass of the object times the acceleration due to gravity times its height. The mass of this particular little Matchbox car is 28 grams, or 0.28 kilograms. The acceleration due to gravity, if I round that, make my math a little easier, that is 10 meters per second per second. And if I multiply that by the height, which we said was 20 centimeters, or 0.2 meters, I get an energy of 0.56 joules. That's how much stored energy I have in that car. And as soon as I let that car run, that potential energy starts getting converted to kinetic energy. As soon as all that height is eliminated, I know all that potential energy is now energy of motion, and I can use that to calculate its speed. So as soon as that height is eliminated, all that stored energy is energy of motion. All that energy has been converted to kinetic energy. I can just simply say the amount of potential energy I started with is the amount of kinetic energy that I had while it was in motion. So I can take this value, set to this value, and set it equal to this formula. Kinetic energy is 1/2 its mass, which is 0.28 kilograms, times v squared. I substitute in my potential energy, which is equivalent to kinetic energy here. I can solve for v. So I put 0.56 joules equals 1/2 times 0.28 kilograms times v squared. If I divide both sides by these numbers and take the square root of that, I get a velocity of 2 meters per second. All right, so 2 meters per second, where we observed about 1.5 meters per second. Why is there a difference? Well, there's friction. These are conversions not incorporating friction. the friction of the track. The longer it's allowed to go on the track, the more that friction is going to oppose its current motion of the car. So I've given you an introduction on potential energy, which is energy of position, and kinetic energy, which is energy of motion. We're talking about the same object, that potential energy can be converted to kinetic energy. You see this, for example, with pendulums. And you pull your pendulum up to a certain height, and you hold it there. That's potential energy. As soon as I let go, the potential energy starts getting converted to kinetic energy. So hopefully that gives you a good introduction to energy, and we'll see you soon with our next video.